My dear friends, welcome to Rajshekhar classes on Applied Data Science with Python. This is lecture number 485. In this lecture, we will try to understand proximity methods. So the big question that we have to answer is how to define the intercluster similarity. Suppose I have given cluster C1 of points, could be one point or multiple points in this cluster, and there is other cluster C2. How do I define the similarity or proximity between these two clusters? There are multiple approaches like min, max, group average, distance between centroids, etc., which are very simple ideas. Let's understand them graphically. Let's understand what are the limitations and advantages of each technique. First, let's see the min approach. Let's assume we have clusters C1 and C2 with the points P1, P2, P3, P4, P5, P6, P7 and P8. What it says is, take the distance between the clusters, take the similarity between the cluster C1 and C2. Similarity between C1, C2 is equal to min of similarity between Pi, Pj, such that Pi belongs to C1 and Pj belongs to C2. What min says is similarity between C1 and C2 is equal to the minimum of the similarity between points Pi, Pj, such that Pi belongs to C1 and Pj belongs to C2. What it literally saying is, take all pairwise dissimilarities or pairwise distances, take all pairs such that one point lies in C1 and other point lies on C2, and pick the minimum of them, which effectively means if you have two clusters like this, like C1 and C2, C1 means what? C1 means my first cluster. Let me say this is my C1, this is my C2. You have two clusters like C1, C2. Pick the two closest points such that one point belongs to cluster C1 and the other point belongs to cluster C2. Pick two closest points or most similar points. That is min, isn't it? What about max? It exactly the opposite. The max is, if I have cluster C1, and cluster C2, let me say I have cluster C1 and cluster C2. This is C1, this is C2. Pick the two farthest, the most dissimilar points and use their similarity as a similarity between cluster C1 and C2. So mathematically speaking, so in min approach, what is the min approach? In min approach, similarity is, in min approach, this is similarity, min of Pi, Pj, such that Pi belongs to C1, Pj belongs to C2. In the max approach, the similarity between cluster C1, the similarity between, in max approach, the similarity between cluster C1 and C2. What is that similarity? Is the maximum of similarity between the points Pi and Pj, such that Pi belongs to C1 and Pj belongs to C2. Pick the two most dissimilar points or the farthest points and use their similarity to define intercluster similarity. Of course, each of them have their own advantages and disadvantages. We will come to that later. The third approach is called group average which says, this is second approach, this is third approach. The third approach is called group average, which says take every pair of points, compute the similarities and take the average. Group average can be written as sigma pi belongs to C1, pj belongs to C2, similarity of pi comma pj by number of points in C1 into number of points in C2. Mod C1 means what? This is size of C1, isn't it? Mod C2 means size of C2. Here you are taking, just see, you are taking every pair of points. Just see, from this to this, this to this, every point, isn't it? That's what it says. Take every pair of points, compute the similarities and take the average. This is called group average similarity. Fourth one is distance between centroids. What is this distance between centroids? If you have these clusters, let me say I have cluster C1 and I have cluster C2. Let me assume my first cluster is C1, my second cluster is C2. Compute the centroid. If you have these points in C1, compute the centroid for C1, isn't it? For second cluster also, we can compute the centroid, isn't it? You have few points in second cluster C2. For them, you can compute centroid. Take the similarity or distance between these centroids as your similarity measure between cluster C1 and C2. This is less popular, so there are many other ways. One thing to note here, one very, very important thing to note here is in min, all you need is the similarity between pair of points. In max also, all you need similarity between pair of points. Similarly, in doing your group average, all you need similarity between pair of points. As we need, this is important point, as we need similarity between pairs of points, we can trivially kernelize it. So instead of this similarity matrix, I can choose any kernel matrix, so the kernel trick can be trivially applied, because all these measures, min, max, etc., all they need similarity between pairs of points, nothing else, isn't it? You need, basically what you need similarity between points. But if you look at centroid method, yes, we will try to understand this centroid method, all these things with the help of numerical examples in future lectures. Here, what is here, min, max, group average, all three of them trivially kernelized, because all they need similarity value and hence they can be trivially kernelized. Just go through this lecture. If you have any difficulty, please keep a comment. I will continue my discussion in my next lecture, that is in lecture number 486. Thank you very much.